So we ended up on some absolute value functions. It is not super difficult. Let's try some more of these. All right, let's look at A. So the idea is the same one from yesterday. You want to see what the number of interest is. In part A, it's 8. And you want to see if you're going above it or less than it. So let's check this out. So it says the absolute value of x has to be less than 8. So you're going to have a negative 8 here. You're going to have a positive 8 here. Are we going to be inside or outside? By that I mean, is it going to be inside this or is it going to be something like that? There's only two options, really. What's the answer to A? The top one or the bottom one? It has to be less than 8.
The
So,
bottom one?
yeah, the bottom one, right? How can you verify this? Just pluck a number. So here's negative 9's there. So I'm going to plug negative 9 as x. So when I plug negative 9 as x, I get a positive 9. Is that less than 8? No, it's not. So this is invalid, right? And the same thing would
Mm-hmm.
happen on this side. So the only way this is going to work is if you're within. Part B is the same thing. So is it going to be, why don't you think about it? Is it going to be inside or is it going to be outside?
It's gonna be outside.
Yeah, that's going to be outside. And you can verify that by just plucking out a number. So absolute value functions, not that difficult. So graph this function and graph g of x. And it says, what do you notice? Mm, okay, so remember your transformations. The minus 8, does it move it to the left or to the right? Or up or down?
To
This
the right.
minus, yeah, to the right. So your parent function, absolute value function, looks like this. Now we're just shifting it 8 units to the right, so it would end up looking something like this. So it has a vertex at the x value of 8, 8 comma 0. So that's
Mm-hmm.
our f of x. Pretty easy to graph. What about g of x? How do we graph that? What's the first thing we do to graph g of x? So you probably don't remember this one. What needs to happen is that the k value always has to be in a bracket inside the function. What's the k value here? So here, I'll help you. So for an absolute value function, it would look like this. It'll be a times k x minus d, absolute value, plus c. So this would be the general form of an absolute value function. So if you compare this one with this, what's our k value?
One.
Negative 1. K is always the number that's multiplied with the x. So k is negative 1. But more
Mm-hmm.
importantly, there's a d value in there, and the k, it's not taken out of the d value. K is not outside of the brackets. So that's the trick in to graph g of x. You have to pull the k out. Step number one. So by that I mean this. So here you have your absolute value function. You're going to pull out that negative 1. What are you left with if you pull out negative 1?
X minus 8.
X minus 8. What does this minus 1 do? Reflection on the x or reflection on the y?
On the X.
It's on the y. It's on the x if it's outside the bracket. If a is negative, it's a reflection on the x. If k is negative, it's a reflection on the y. So that negative 1 is a reflection on the y-axis. So we know our parent function is symmetrical, looks like this. If you reflect this on the y-axis, would anything change?
No.
Yeah, no, because you're gonna get the exact same thing. So reflection on the y-axis doesn't change anything. So we're dealt with the -1. Now the -8, it just shifts it 8 units to the left. So all in all, our f of x and our g of x, they end up looking exactly the same. They're the same curve. Okay?
Mm-hmm.
So that's the answer to part A. We notice that the curves are exactly the same. Part B, how could you have predicted this? Well, the negative of anything, the absolute value makes it a positive, yeah?
Mm-hmm.
So here the negative is outside of the bracket. So when you take the absolute value function, that negative sign gets canceled out. So you're just left with absolute value of x minus 8, which is what this is. So we could have predicted this by just taking the absolute value of the -1 of the k value. Okay?
Mm-hmm.
That's it. Okay, what about this? How do we get there from the parent function? So there's two transformations that are happening here, okay? There's the +3 and there's the -4. It's easier than you think. The +3 is inside the bracket. That's going to be our D value. -4 is outside the bracket. It's going to be our C value. Is the D positive or negative? It'll be negative. Because if you remember, the general form is always kx minus d. By default, it comes with a minus sign. So there's a plus sign in here. The d is going to be negative. So all in all, your new function would move 3 units to the left and 4 units down. And it would look something like this, where this point is -3 and -4. Cool?
Mm-hmm.
Not that difficult. So let's move away from the absolute value functions. Let's see if there's any dicey questions here. Okay, let's look at this one. So now we're exploring properties of a function. So the parent function here is 2 to the power of x. It's an exponential function. And just recall about exponential functions. It looks like this. The parent function will always go through the y-intercept of 1. And there is an asymptote down here. Exponential functions cannot cross the x-axis. So let's look at this question part by part. Part A. The graph is decreasing. Is the graph decreasing or increasing?
It's increasing.
It's increasing, so A is wrong, right? It's not decreasing. It's always increasing perpetually, so A is out. B, the graph is continuous. Remember what continuous is? Continuous is something that doesn't have a gap. In other words, it doesn't have a vertical asymptote or a hole.
Mm-hmm.
If it doesn't have either one of these two, we call it continuous. Is this graph continuous?
Yes.
Yes. So B is true. C, the function p of x is an even function. Remember what even function is? Even function is like absolute value function or x squared. Even function is perfectly symmetrical on the y-axis. So when you flip it on the y-axis, nothing changes. That's an even function. Is this an even function?
No.
No. Is it an odd function?
Yes.
No, it's not. Odd function also has a symmetry. but it's not about it's not on the y-axis, it's about the origin. So an example of an odd function is this. It's a terrible example. Maybe something like this. It is symmetrical, but like diagonally symmetrical. That's an example of
Mm-hmm.
an odd function. Another one would be something like this. This is an example of an odd function. Another would be sine of x. So is this exponential function an odd function?
No.
No, it is not. So C is, it's neither odd nor even. Part D, the function p of x has no zeros. Remember what a zero is. Zero is an x-intercept.
It doesn't.
It does not have. So that's true. This question is a little bit tricky. It says, determine a possible transformed parent function that has the following characteristics. I'll give you some options. I'm gonna cheat. Dave gave us some functions earlier here. We're just gonna focus on these guys. Um, all right. So the domain has to be XCR. Which one of these four functions has a domain of XCR?
The first one?
First one, yeah. What about the second, third, and fourth? Is their domain XCR or is it something else?
It's XER.
It's XCR, right? So the first condition is satisfied by all four plots. So the first condition doesn't really help us. The second one will help us. Range y is greater than equals to something. What's the range for the first function?
It's YER.
It's YER, so it can't be this one. 2 to the power of x. Will it ever be inclusive for an exponential function? The minimum value?
No.
No. An exponential, the asymptote or the minimum value, will not be inclusive. It's strictly greater than. So it cannot be exponential either. Same thing for sine of x. For sine of x, what does a range look like? It's between two different y values, yeah? It's
Mm-hmm.
between -1 and 1 for sine of x. So it can't be that one either. So the only thing that we could do is the absolute value function. So that's our function. We've deduced that it's absolute value. Y is greater than equal to -2. Is that going to be our minimum value or our maximum value?
Minimum.
Minimum. So at -2, we have our minimum. And it's decreasing on the interval -infinity to 0, and it's increasing on the interval from 0 to positive infinity. So there you go. It's decreasing here. There's -infinity here. 0 is there, so it's decreasing. And over here, it's increasing. And that would be a possible solution to this question. There's an infinite number of answers. Another one would be maybe a quadratic. You could do it like this. You could put it there. You could put it here. Really, you can put it anywhere as long as the minimum value is -2. And it's opening up. Okay?
Mm-hmm.
So I think that is the answer to this one. Okay, now let's deduce if something is odd or even. So here are the conditions for something to be an odd function and something to be an even function. Graphically, it's pretty easy to understand. An even function is symmetrical around the y-axis. That's graphically. Mathematically, from a formula standpoint, even function is this. They will give you some function f of x every single time. So what you do is you want to check if f of minus x is equals to f of x. If this condition holds, then it's going to be an even function. An odd function is symmetrical around the origin, something like this. And the formula that you want to check for looks kind of similar to the even one. There's one difference. F of minus x needs to be equals to negative f of x. That minus sign inside of the function needs to come outside, okay?
Mm-hmm.
So let's see how this actually works. So part A, they've given us f of x. F of x is x squared minus 4. So what you do is you plug in f of negative x. If f of x is x squared minus 4, what's f of negative x?
Negative x squared plus 4.
So like this? Is that what you meant?
Mm-hmm.
So that's incorrect. So let's see how this actually works. So all you have to do, okay, we did this when we are doing the x plus h stuff. You're gonna replace the x, only the x, with what you have in the bracket. So look at this. That x is going to be replaced by negative x. We square it. The minus 4 remains unchanged because it doesn't have an x.
Mm-hmm.
So this becomes x squared minus 4, which is the original function that we started off with. So we put a minus sign in there, and we ended up getting the original function back. Is it odd, even, or neither? Look at which condition was satisfied from here to here. F of negative x, right? We plugged in the negative value for x. We ended up getting the original function. So
It's
therefore
even.
it's even, right? Yeah, exactly, it's even. And very easy to graph. You can see it graphically as well. X squared minus 4 looks like this. It has a vertex at negative 4, so it's perfectly symmetrical around the y-axis. It is an even function. Okay?
Mm-hmm.
B is hard. I don't know why this is here. Sine x plus x. Not a whole lot changes though. So let's plug in f of minus x. So why don't you tell me, if this is f of x, what's f of minus x?
Sine of negative x minus x.
Yes. So sine of negative x minus x, yeah?
Mm-hmm.
Now let's talk about what sine of negative x is. Sine of negative x. Let's say this is your angle x. In which quadrant is the angle negative x? Let's say this is 30. In which quadrant is the angle minus 30? Remember negative angles? It's clockwise. Negative 30 would be this way, okay?
Mm-hmm.
Clockwise from the x-axis. So if this is x, where is negative x? It's gonna be in quadrant 4, okay? Quadrant 4.
Mm-hmm.
Is sine positive or negative in quadrant 4? You were using the CAST rule, C-A-S-T.
It's negative.
It's negative. So sine of negative x is equivalent to negative sine of x. Because sine is negative in quadrant 4, that negative sign comes outside. On the other hand, if it was cos of negative x, that would be equals to cos of x. The negative sign disappears because cosine is positive in quadrant 4. Okay?
Mm-hmm.
So we get this. So this doesn't really look like anything. So what I'm going to do is I'm going to pull out a negative sign. If I pull out a negative sign, I'm left with sine x plus x. And this is my f of x. So what do I have in total? In total, I started off with f of negative x, and at the end, I got f of x, the original function that I started off with a negative sign outside of it. So is this odd or even? Or neither? We always start with the negative sign inside of the f function. What we're interested in is where do we end up? Is this
It's
odd or even?
on.
It's odd, okay? It's odd. So we can graph it as well. Graphing this by hand is not super simple because you have a trig function and then you have a linear function. So it's a combination of functions, but when you do graph it out, you'll get something like this. As you can see, it looks like y equals x kind of in terms of its symmetry. Whatever you have in quadrant 1, you have in quadrant 3. So that's symmetrical around the origin, therefore it is an odd function. Is that making sense?
Mm-hmm.
Okay, we'll maybe just do one or two more of these guys. Let's do C. If f of x is 1 over x minus x, what's f of minus x?
1 over negative x plus x.
Yes. Now this doesn't really look like anything we had in the beginning. So what I'm going to do is I'm going to take out a negative sign. If I pull out a negative sign or a negative 1, what am I left with in the bracket?
1 over x minus x.
Yes. And what is this? That is f of x,
Even.
the original function. So is this odd or even?
Even.
No, in an even function, the negative sign disappears completely. Here, we pulled it out of the f of x term.
So
So,
it's odd.
so it's odd. Yeah, exactly. So we can graph it quickly just to show you, just to prove that it is odd. I don't know why it looks really weird. It looks kind of like that. I'm confused with this diagram. Can x be 0? What's the domain of this function? Okay, I have to zoom in really hard. Okay. So as you can see, this one is also symmetrical around the origin. It's like putting a mirror around the origin. Not on the x-axis, mind you. I'm not saying we're putting a mirror on the x-axis. We're putting a mirror at the origin. So whatever you have in Q2 goes into Q4, Q1 goes into Q3, okay?
Mm-hmm.
Because it was initially like this, and I was super confused because I know for a fact that x cannot be 0, the domain. Yeah. So it looks like this and it checks out. That is an odd function. We'll do one more. We'll do maybe f, the absolute value function. Actually, I'll just show you, okay? I'll do maybe e. I'll do e. Not every time will it be an odd function or an even function. Sometimes it's gonna be neither. And I think this is gonna be one of them. So f of negative x will be 2 times negative x squared minus negative x. So this gives me 2x squared plus x, which is neither, it's not f of x, it's not f of x. So what is this? Odd, even, or neither? It's neither. You can also try pulling out a negative sign. You'll see that that looks nothing like your f of x function that you started off with. So,
Mm-hmm.
so this one would be neither. Okay, let's move away from this. Here's a question, and this is an exam question. It's tricky. Okay, so we're supposed to draw a graph using these conditions, and they're independent. So A is independent from B, and it's independent from C. So let's look at A. The domain is XER. So that gives us a bunch of options. So let me just draw this out. Y equals X. I think that's about it. Maybe the root function as well. We can also use the root function. All right. So these are the possible functions. Let's look at A. The domain is XER. All of these are in. This is also in. So the only ones that are not in is the last two. It has an interval of increase of negative infinity to positive infinity. So it's only increasing, okay? It's only increasing, and the range, the y value in the range is exclusive. The -3 is not inclusive. So which one of these functions fits the criteria? It has to be strictly increasing, and the minimum value is exclusive. There's only one function. Which one is it? The minimum value is exclusive, means there's an asymptote there. And out of the ones that we've highlighted, there's only one
The,
function.
the exponential one.
It's the exponential one, that's it. So for this one, -3 is here, and it's increasing, so we can say it's 2 to the x minus 3 as the answer, okay?
Mm-hmm.
That's the answer to part A. Part B. The range, now it's not talking about the range, as domain is talking about the range. The range is in between two y values. Which function has a range that's between two y values? There's only one. Every other range is either XCR or y is greater than something. There's only one function that has a range that's inclusive between two numbers. It is going to be the sine function, okay?
Mm-hmm.
Sine function is the only one that has a range value between two numbers. Because if you look at them, this is XER, this is y is greater than 0, y is YER, YER, y greater than equal to 0, y just strictly greater than 0, y greater than equal to 0, y cannot be 0, y greater than equal to 0. The only function that has a range between two values is sine x. So for part B, it says draw a possible graph. So we're going from 2 to 4. Sine x starts in the midpoint. So it'll look something like this. And it goes forever in both directions. That's the answer to part B. Part C, again, they're telling you that x cannot be something and y cannot be something. There's only one function here that states the domain and range like this. It's only going to work for one of these functions. Which one is it? It's 1 over x. That's the only function that has a restrictive domain and range. That's the only one that
Mm-hmm.
lists domain and range as x cannot be something, y cannot be something. So the range cannot be -3. The domain cannot be +5. So your graph would look like this. In the equation, again, we can just use transformations, right? Because this is the parent function. We moved 5 units to the right, so 1 over x minus 5. Remember, inside the function is the opposite. So that would move it 5 units to the right. And now we're moving 3 units down, so it'll be 1 over x minus 5 minus 3. The c value needs to be outside of the function, so that would be the equation for this plot. And you're
Mm-hmm.
done. But this type of question is definitely difficult and one they will ask you. Okay, let's try another one. It's the same kind of idea. But here it's even more difficult because they haven't told us what the domain and range is. So it says sketch a possible graph. All right, let's try it. F of 0 is -1.5. So your y-intercept is at -1.5. F of 1 is a 2. So we know our plot goes through this point and goes through this point. Furthermore, it says there's a vertical asymptote at -1. So there's an asymptote here. As x gets positively large, y gets positively large. So these are your end behaviors. So as x goes to positive infinity, y goes to positive infinity. So that's a big hint. Basically, what they're telling you is on this side of the plot, you'll be somewhere here, up there. X is infinity, y is infinity. And on the other side, as x gets negatively large, so as x goes to negative infinity, y is gonna go to 0. So on the right side, we end up somewhere here. On the left side, we end up somewhere here. Y approaches 0 means y will never be exactly 0, but it'll try and get there. So overall, our plot, it just says sketch a possible graph. So it'll look like this. There you go, that's the answer. Cool.
Yeah.
Again, there's many answers, whatever works best for you, as long as you're satisfying all of the conditions. Let's move away from these guys. Remember the greater than less than? Is a function or no? From the mapping diagram here. We talked about this one
It
yesterday.
is.
It is, yeah. B is a linear function for sure it is. What about C?
It's not.
C is not. What about D?
It's also not.
It's also not because the X value is repeating. Determine the domain and range for each function and state whether or not it's a function. So part A is very simple. What's the domain and range for part A?
It's x here and y here.
And what about is it a function?
Yes.
Yeah. What about B? Is B a function? So B is a circle, remember? Yeah?
So it's not.
It's not. What's the radius of the circle in B?
It's 3.
It's 3, so the domain is going to be -3 to 3. The range is going to be also -3 to +3. It looks like this. So this is your domain, and this is your range. That's the radius of the circle. Part C, 5 minus x. I'll give it to you, this one. So it's going to be a times k x minus d plus c. Compare this with the square root function. What's a, k, d, and c?
A is 1.
A is 1, so you can ignore it. What about k?
K is 1.
K is -1. K is always the number that's multiplied with the x. I'm going to write it like this. So as you can see, k is -1.
Mm-hmm.
What about the d? That's a trick
It's
question.
5.
It's +5. I think you fluked it. It is right. So what you need to do is you need to take out the minus sign here. Always, the k needs to be in a bracket. It needs to be outside of the bracket. So when you take the -1 out, you get x minus 5 inside the function, which makes d a +5. And c is 0, so you can ignore this. So what does k equals -1 do to the function? Reflection, stretch, translation, what does it do? K, -1 is a reflection on the y-axis. Okay, if A is negative, it's a reflection on the x-axis. If K is negative, it's a reflection on the y-axis. So here, what's going to happen is this. We're going to start with the parent function. Squared function looks like this. It's a reflection on the y-axis, so it's going to flip the other way like that. The 5, d equals 5, is going to shift it 5 units to the right. So all in all, your function, final transform function, looks like this. What's the domain and range of this function? Start with the domain. It's a function, we know it. What's the domain?
It's less than 5.
Can it be exactly 5?
Yes.
Yes. What about the range?
It's greater than 0.
Can it be exactly 0?
Yes.
Yes, perfect. There you go. That's the domain and range. The last one there, D, is a quadratic, and always write it in the right form. So what I'm going to do is I'm going to move the y. Y goes this side, 2 goes on the other side, like that. So here we have a quadratic. We know it's going to be XER, and they've given us the y-intercept -2. So the range will be y is greater than -2. So very simple for the quadratic. Yeah, super
Mm-hmm.
easy. Determine a parent function that matches the set of characteristics. So for part A, it says it's neither odd nor even, and as x goes to infinity, y goes to infinity as well. All right. Which one of these functions is neither odd nor even? I'll give you a sketch if that'll help. You don't need for most of them. You know what x looks like, you know what x squared looks like, you know what cubic looks like. Sine x looks like this. It's It's an even function. 2 to the power of x looks like this. Root x looks like this. Absolute value looks like a v. 1 over x looks like this. So which one of these functions is neither odd nor even? There's only two. So let's look at 2 power x. What's 2 power x? Odd or even? Or neither?
It's neither.
Yeah, it's neither. What about root x?
It's also neither.
It's also neither. So both of these satisfy the first condition. Which one satisfies the second condition? As x goes to positive infinity, y goes to positive infinity as well. It's between 2 to the power of x and root x. Which one satisfies the second condition?
2 to the power of x.
Actually, both of them, okay? Both do. Because even for root x, when you go all the way here to negative infinity, you'll see that you're gonna grow, and you'll get to positive infinity. So both of these functions are good for part A.
Mm-hmm.
Okay, part B. What is that? Negative are both intervals of decrease. So it's decreasing. I'm looking at the next question. It's decreasing from negative infinity to 0, and also from 0 to positive infinity, it's decreasing. So it's decreasing pretty much everywhere. Which function shown here? There's only one that's decreasing everywhere. Which one is it?
1 over x.
1 over x, and that's the answer to B. Part C, the domain is 0 inclusive to positive infinity. Which one fits the bill?
Root of x.
Root of x, perfect. So again, remember the parent functions. Each set of characteristics describe a parent function that has been shifted. Draw a possible graph and state whether or not it's continuous. Cool. Part A, there's a vertical asymptote. Automatically, there's a vertical asymptote. Is it continuous?
No.
No. But on top of this, there's also a horizontal asymptote. So for part A, it has two asymptotes. The only function with two asymptotes is 1 over x. So it has it at 1, it has it at 3. Can you tell me what the equation for this could be? Look at what we did with there. We did two transformations. Both of them are shifts. So compare this to the parent function. Look at what happened to the asymptotes. It shifted right by 1 unit
Mm-hmm.
and it shifted up by 3 units. Shifted right by 1 unit, x minus 1. Shifted up by 3 units, plus 3. And that's the equation. It is not continuous because there's a vertical asymptote. Cool?
Mm-hmm.
That's it. Horizontal asymptote is fine. It doesn't dictate whether or not something is continuous because 2 to the power of x has a horizontal asymptote. It's still continuous. It's the vertical asymptote that dictates that. Part B, again, okay, look at this. The range is between two values. There is only one function that has a range between two values. Which one is it? It's a trig
Sin
function.
x.
Sine x, exactly. So for this one, -1 to -3, sine always starts in the middle. So your sketch would look something like this. It goes on forever. An equation could be sine of x minus 2. Because a parent, actually, let me think. Minus 2 works. Because the original function has a domain of 1 to negative 1. This is the parent function. So all we did to this was we shifted it 2 units down, right? Yeah. So that would be the equation. We just shifted the parent function 2 units down. Part C, the interval of increase is negative infinity to positive infinity. So that means it's continuous. There's no break in the curve, it's continuous, and it's increasing everywhere. On top of this, there's a horizontal asymptote. So what's a function that satisfies these conditions? Nope. Which function has a horizontal asymptote?
Exponential.
Exponential, and that's the answer to this. So you could have something like this. There's a horizontal asymptote at negative 10, and your function looks something like this. So you can say that's 2 to the power of x minus 10, and you're done.
Mm-hmm.
That's it. Okay, again, we're going to list them out. X squared, x cubed, sine x, 2 power x. It says sketch a graph. The first requirement, the function is odd. Which one of the functions here is odd, if any? Which functions are odd?
X cubed.
X cubed. So x squared is out. What about x?
It's also odd.
It's also odd. What about sine x? Sine x
No.
is even, but cosine x is odd. 2 to the power of x is neither. Root x, sorry, absolute value of x is even. Root x is neither. What about 1 over x? Odd, even, or neither? One over x. Think about the graph. Look at the graph.
It's odd.
It's odd. So from the first point, we've isolated 4 functions. Second point, the function is continuous. Which one of these functions is continuous? Or which one is not?
1 over x is not.
1 over x is not, so that's out. 3, the function has zeros at x equals minus 3, 0, and plus 3. So it has 3 zeros. Can x have 3 zeros? The function y
No.
equals x? No. So it's between these two. The function is increasing on the interval negative infinity to negative 2. So this one, cosine x looks like this. It's always increasing and decreasing, okay?
Mm-hmm.
Depending on what the period is. This says it's flat out decreasing or increasing from negative infinity to all the way here. It's a flat increase. Cannot happen for cosine of x. Cosine of x has to increase and decrease every once in a while, depending on the period. It's just too big of a range, this one and this one, both of them. So this function is not cosine because cosine would increase and decrease multiple times over this range, right? Not just
Mm-hmm.
once. It's gonna increase, decrease, increase, decrease forever. And function is decreasing. All right, so we know, well, the one function that works is x cubed. So let's try this out. It has zeros at negative 3, 0, and positive 3, like that. The function is increasing on the interval -infinity to -2. So it's increasing. So -2 is here. So let's do, it also has to have an intercept of -3. And it's decreasing from -2 to 2. All right, I think I get it. So, but it's a cubic function. Hmm. Does that work? I'll say this is 2. Does this work or no? What do you think?
It does?
It does, right? Because -2 is here, +2 is there. It's decreasing on that interval and it's increasing everywhere else, right? Yeah. So it checks out. So this is definitely a difficult question, and you should expect something like this on the exam. But when they say continuous, you eliminate the more difficult functions, such as 1/x. So it makes things a little bit easier. Yeah?
Mm-hmm.
Okay, what does a 3 do? What does a 2 do here? What do both of these things do? Your parent function is √x. So I'll give this to you, right? This is the general form, okay? This is the general form A, and f is any function. This general rule applies to any function. This is the general rubric. For a square root function, look at this, okay? You need to know how to construct this. A is always going to be outside of the function. A is always outside of f. And f in this case is your square root function. The function is a square root function. K doesn't have a k. Well, this does not, but it will look like this. So when you compare this with this, you'll see that A is 3. What's K?
It's 1.
It's 1. What's D?
It's 2.
It's 0. What's C? It's -2. D is inside the function. It should be inside of the square root, right? The -2 is
Mm-hmm.
outside, so that's how we know it's not a D value, it's a C value. So in terms of the transformations, what does this do? Well, it's a vertical stretch by a factor of 3, and it's a vertical translation down, or a vertical shift down by 2 units. So look at this. I'm not going to be super precise here. You can use a calculator and grid paper. But your parent function looks like this. What we do is that the order of the transformation is important. It's relevant. You always do stretches and compressions, okay, stretches and compressions before you do shifts. If you're using this rubric and I'm using this, I'm sure this is the same thing that you guys do in your province. The letter might be slightly different. They might call this P or something, if I remember, HK or something. But the idea is the same. You're always going to do stretches, compressions before you do shifts. So this is our parent function. What we do is we stretch this by a factor of 3. Remember what that means? Your x values stay exactly the same. Your y values, they get multiplied by 3, like that. And
Mm-hmm.
then you have to shift this entire thing 2 units down. So just bring it 2 units down. And there you go. The one in green is going to be your final answer for this question. Okay?
Uh-huh.
So not terribly difficult. All right, let's call it there for today.
Okay, thank you.
See ya.